All right, in problem number 30 here, you are combining fractions. So what you need to do for each one is first make sure that they're written as factors. So my first fraction is just fine. My second fraction, though, I do want to reorder the terms in the denominator. I also want to make sure that my leading coefficient's not a negative. So I'm going to factor out a negative and reorder these terms. The 3 becomes a negative 3. The negative x becomes a positive x. Okay, and then in my last fraction, same. I'm going to factor out a negative first, giving me an x squared minus 7x plus 12. And then I'm going to factor this trinomial. So I still have my negative here. I'm looking for my binomial factors. My first terms have to be x's. My second terms are the two factors of positive 12, whose sum is negative 7. So negative 4 and negative 3 work. So I'm just simply rewritten all of those denominators as factors. And when I take this minus, really any factor of negative 1 just move up to the numerator. So that moves up, this one moves up. And in both of these cases, when you take and subtract a negative, it's equivalent to adding the opposite. So it winds up canceling the signs. Okay? So now I've got my expression. I can combine it into one single fraction and find the LCD for this. So I need a factor of x minus 4. I need a factor of x minus 3, x minus 4, and x minus 3, which I already have. So here is my LCD. My next step is to take the numerator of my first fraction, multiply that by the LCD factor missing from its denominator. It has the x minus 4, it's missing the x minus 3. Plus my next fraction's numerator, 1, times the LCD factor missing from its denominator. It has the x minus 3, it's missing the x minus 4. And then finally, plus my last fraction's numerator, 1, times the LCD factors that are missing from its denominator. It's not missing anything, so just leave it as the 1. Okay. When I distribute these 1's through, 1's an identity, so it's just going to leave the expressions just as they are. So I can combine my like terms. X plus x is 2x. Negative 3 minus 4 is negative 7, plus 1 is negative 6. I can continue to simplify, or I can look to factor this, removing a common factor of 2 times x minus 3. The denominator stays just as it is. And my final step is to cancel common factors, which I do. And I get my solution. And when I go back and look here, all I need to do is look for any factors that got canceled from my denominator to find my domain restrictions. So I see x can't be 4, but that's shown in the simplified form. X can't be 3, that's not shown. So I need to exclude that as an additional restriction.